G'day, welcome to this episode of the ADF Architecture TV channel. My name's Chris Muir, I'm an ADF product manager and I work for Oracle Corporation. It's probably kind of obvious. So in today's episode of the Architecture TV channel, we're going to talk about an extension of the previous presentations. We're going to talk about the bounded task flow transaction options this time instead of the data control scope options. And the transaction options are a somewhat, let's say, tricky feature, but it does provide some benefits if you do want to use them. And over this episode and the next episode, we're going to talk about the options, what they do, and also talk about the benefits and some of the nuances of actually using these options in your applications. My end goal here is to make designers, architects, senior dev leads, development leads aware of what these options do when you need them and when you don't, and when you should be thinking about designing for them. So let's crack on. Now before we actually talk about the transaction options today, we want to talk about a concept before that will make understanding the transaction options a lot easier. And this is an internal runtime object called the data control frame. So from the previous episodes of the Architecture TV channel, we know that the bounded task flow is one of the major design artifacts or modules of putting our ADF applications together. And from the very recent episodes on the data control scope options of bounded task flows, we know through that option and the shared and isolated data control scope options and chaining bounded task flows together, effectively we can delineate the transaction boundaries of a number of pages in our bounded task flows. We can delineate those transactions for the purposes of building our applications. So for instance, in a shopping cart application, once I call a bounded task flow and it has an isolated data control scope, we're starting a transaction, and then that BTF, that bounded task flow, might call multiple other bounded task flows with a shared data control scope. All of those constitute the transaction of our application, and then at the end we finalize with a task flow return, commit, or rollback. So from a design time perspective, we understand where these boundaries lie, and through the declarative settings of the data control scope option, we really influence those transaction boundaries. But at runtime, how does ADF actually track those transactional boundaries? And you've got design concepts of bounded task flows, but there must be some sort of internal object that ADF uses to work out where those transaction boundaries are, what bounded task flows are attached to those transactional boundaries or within a set of transactional boundaries, and what screens and what data control instances, which again we alluded to in the previous episode. Now the main object that is responsible for that is an internal object called the data control frame, okay, the data control frame, or the DCF for short. Now this is a runtime concept, it's in fact a runtime class, and you won't find a lot of documentation about this guy. There is some documentation about him in the development guides, but mostly you'll find him mentioned in the Java APIs, specifically the ADF controller APIs. And again, he is in a runtime object, so this kind of makes sense why he's not documented exclusively in the dev guides, because he's something that you would only encounter at runtime. Now what the data control frame is designed to do is to group disparate task flows that are chained together and their data control instances at runtime. So ultimately he is designed to say, well, if we've got a number of BTFs that are calling each other and the first BTF has an isolated data control scope option and all the others have shared, and there are a number of data control instances used within that bounded task flow chain set, then basically he is the one, the data control frame I should say, is the guy that tracks all those bounded task flows that are a part of that group and all the data control instances that are used within the data control frame or reference within the bounded task flows themselves. Now, in terms of the data control frame, when does it get created at runtime? Well, at any point in your application, if you have a bounded task flow with an isolated data control scope option set, okay, a brand new data control frame will be created for you. Alternatively, if you have a bounded task flow that is called and it has a shared data control scope option set, then it will not create a brand new data control frame. It will use, or I should say, join the data control frame of the previous bounded task flow. Okay, so let's very quickly say that again. The isolated data control scope, if that's set on a bounded task flow, it will always create a new data control frame. Alternatively, if you have a shared data control scope of a bounded task flow, when it's called, it will not create a new data control frame. It will join the previous data control frame of the calling bounded task flow. Just before we move on from there, a little caveat: what about unbounded task flows? Now, they don't have data control scope options, or transaction options for that matter. So if they don't have data control scope options, what's happening with the data control frame there? Well, for all intents and purposes, an unbounded task flow you can consider to have an isolated data control scope. Now, with all that in mind, let's have a look at this diagrammatic example, which will help explain the boundaries of the data control frames and when they're created and when they're not. Now, as you can see in this particular diagram, we start out with our typical unbounded task flow that every ADF application has to have. And the unbounded task flow, as we said in the previous slide, basically can be treated as an isolated data control scope, and therefore it gets its own data control frame, in this example number 1. Now, the unbounded task flow, or UTF number 1 here, at some point is going to call some other bounded task flows. And in context of this application, the bounded task flow that's going to first of all allow to be called and the user might navigate to is bounded task flow number 1. And in this specific case, bounded task flow number 1 is configured with a shared data control scope. Now, because bounded task flow is configured with a shared data control scope, it does not create a new data control frame. Rather, it joins the data control frame of the original task flow, in this case UTF-1. So it joins data control frame 1. In turn, BTF1 may call other bounded task flows, and there might be a whole series of them. And as long as those bounded task flows specify a shared data control scope, they are always going to, in this example of this application, join data control frame 1. Now, at some point in this particular example, let's say the unbounded task flow is configured to call another bounded task flow number 4. Now, in this particular example, bounded task flow number 4 is not configured with a shared data control scope, but rather it's configured with an isolated data control scope. So what happens in this case? Well, it doesn't join data control frame 1. Rather, a brand new data control frame is created in this context, this example number 2. Now again, for the configured application, we have all sorts of options here, but for this application, it then by chance calls bounded task flow number 5, and that has a shared data control scope. So in this context again, it doesn't create its own data control frame because shared never creates its own data control frame. Rather, it joins the data control frame of the calling task flows, and in this case, this is data control frame number 2. Just to complete the example, say shared bounded task flow number 5 then calls an isolated data control scope bounded task flow number 6, well again, a brand new data control frame here is created. If that then calls a shared data control scope bounded task flow number 7, well that would join data control frame number 3. So hopefully this little diagram here gives you an example of, or explains when data control frames are created or when they're basically reused by bounded task flows. So now that we've considered the data control frame, which will make the upcoming discussions easier, let's discuss the transaction options configured on the behavior tabs of your bounded task flows. Now, what the transaction options are designed to do is to implement transactions or abstract the transaction concept not down at the data control instance layer, but to bring transaction controls up to the bounded task flow or controller layer. So basically we're introducing these concepts of transactions such that the controller can organize and handle the transactions itself. Now, to be clear, the data control instances under the covers still are ultimately what handle transactions, such as the ADF business component, data control, talking and connecting and issuing commits and rollbacks to the database. But what we're trying to do is track and control that transaction now at the higher level, at the controller level, and when it needs to do commits or rollbacks or define the boundaries, it will use the data control instances to do that. Now, the transaction options at the controller layer or the bounded task flow layer are designed to provide a JTA-like transactional type facilities. Now, to be clear, JTA isn't used under the covers, but the development teams, when introducing this set of features to bounded task flows, use JTA as a set of guidelines for what features they wanted to implement. Now, ultimately, what this set of features is designed to do is when you have a set or a chain set of bounded task flows, which have a number of different data control types or instances associated with the current data control frame and those bounded task flows as a result, it's designed to allow them as a heterogeneous set of services to be committed or rolled back as a group. Now in the previous episode from the data control scope option, I was always kind of talking about ADF business components, and that's not really a heterogeneous set of services. But for the transaction options, this really is designed to allow you to use all the different data control types and allow them to commit and roll back as a group. Now ultimately this feature, this group-like feature of committing and roll back all these bounded task flows is defined by your bounded task flow boundaries that you define at design time, your bounded task flow calls that essentially chains your bounded task flows together, the data control scope and transaction options that you pick, and also the task flow return activities with commit and rollback. Now we'll go through these options in a little bit more detail, but there is one significant feature of the transaction options that applies to specifically ADF business components that you need to be aware of. Now I just talked about that these transaction options are designed to allow heterogeneous services or data control types to commit and roll back as a group. But if you have disparate ADF business component data controls in your application, now when are you likely to have that? When you have a number of ADF libraries with their own bounded task flows and their own application modules connecting to an Oracle database through ADF BC. What the transaction options can do for you in this case is when you use the transaction options and a bounded set of bounded task flows is grouped together under one data control frame, at runtime, even though you may have multiple root application modules configured in your application, what ADF and the controller will do at runtime is you can even still have those disparate ADF business component instances, but the connection or the disparate connections behind all those ADF business component data controls will actually be shared at runtime. So while typically root AMs all have their own connection to the Oracle database, if you use the transaction options that we're going to talk about, what you'll discover is they will actually share the same database connection behind the scenes. Now we are going to talk about that feature in a lot more detail in a future episode, but it does give you an idea why you need to investigate these options, particularly if you're using disparate set of ADF libraries with their own bounded task flows and their own application module instances. Anyway, let's go back to discussing the actual transaction options themselves. Okay, so by this we're going to look at the 4 options that are available from the bounded task flow behavior transaction options pop list. So in considering the transaction options, let's actually talk about what the 4 values are actually called. There's always begin new transaction, always use existing transaction, using the existing transaction if possible, and no controller transaction. Now in the history of JDeveloper 11G, at one point these transaction options had different names and they got a little bit confusing, but Oracle saw, I guess, the folly in its ways and renamed some of those options, and I just referred to them there. But if you go back into the bounded task flow XML file for backwards compatibility, when you pick those particular options, as you can see on this slide here, that those XML, well, those options are represented in XML and they have slightly different names. It's only a very minor point, but it's worthwhile noting because even in some of the documentation, we're a little bit inconsistent on that in older versions, and you'll find in newer documentation where we're very much tightened up on that. So just to warn you about the little bit of confusion that you can get into in this space. So the always begin new transaction option, what does this do? Well, specifically when you set this option, it actually signals or sets the token on the data control frame that a transaction is underway. Okay, so this option sets the data control frame and all subsequent bounded task flows that will join that data control frame that a transaction is underway for that set of bounded task flows. Now, the always begin new transaction option and all the transaction options are always set in context of the data control scope option as well. Now, depending on the transaction options that you set, sometimes the data control scope option will be enabled, and other times Oracle, or I should say JDeveloper, will preset this for you and make it read-only. But in context of the always begin new transaction option, the data control scope option, well, is enabled and you can set it to isolated or shared. So let's just think about that for a second. We want, with the always begin new transaction option, to delineate the beginning of our transaction boundary in our data control frame. Now, if you think back to the data control scope options, if we set it to isolated, this would create a new data control instance, and obviously this was also delineating the beginning of our transaction in our ADF application. So typically you would want to set the always begin new transaction option with an isolated data control scope. That makes sense? So you obviously are coordinating these two options to influence not only what data control instances are created, but also from the abstraction of the transactions at the controller layer where those boundaries of your ADF transactions occur. So it's really up to you to get this combination of options right. Now conversely, you can set the shared data control instance option for your bounded task flow with the always begin new transaction option. It is a viable option, but in reality it gets to be a rather confusing situation, because in this case you can have data control instances that are shared from previous bounded task flows, and they may have an actual transaction, say with a database underway, but from a logical perspective at the controller layer, you're saying the transaction starts at the current bounded task flow. Now, while that's allowed, I highly recommend that you don't do that sort of combination of options, because it's just darn hard to understand what's going on. So very much, if you're going to use the always begin new transaction option and your intention is to start a transaction, also set the isolated data control scope option such that the data control instances are created and primed for the boundaries of your new transaction. A further little caveat about the always begin new transaction option is later on when you chain more bounded task flows to the overall data control frame with its transaction token, even though the other bounded task flows at some stage might attempt to call a task flow return commit or rollback, in that case those commit and rollbacks will be ignored. Only the initial task flow, bounded task flow that starts the overall BTF transaction, or I should say the data control frame transaction, can actually issue a task flow return commit or rollback at runtime. And it will obviously not only commit and roll back the data control attached to that bounded task flow, but all the data controls attached to the overall set of bounded task flows. Now that's a little confusing, and possibly a little complex to talk about now. So again, we'll talk about that specific set of options in a future episode. But coming back to it, if you want to, in a set of bounded task flows, which are ultimately grouped together in a data control frame, to basically say to the controller layer, this is a transaction underway, you would use the always begin new transaction option. Now conversely to starting transactions, sometimes we're going to want to create bounded task flows where they don't want to start a transaction. In fact, all they want to do is join a transaction. Now, if I can give you an example, imagine a shopping cart set of bounded task flows. Now, in a shopping cart scenario, you typically enter your customer information, you typically enter the actual items that you want to buy, and then your credit card details. Now, in context of if they were 3 separate bounded task flows that we were chaining together, you'd really potentially only want the first bounded task flow to create the transaction token on the frame, and the other bounded task flows to join that frame and not start a brand new transaction. In fact, it would be not ideal if they started a separate transaction to, for instance, allow you to enter the shopping cart details in a separate transaction from the customer's, as example, address information and pricing information. So in that scenario, we really do need a transaction option that says this BTF is not going to start a transaction and wants to join a transaction on the frame. So that option is the always use existing transaction option. And essentially this option says is, well, when I join a set of bounded task flows, essentially there's a data control frame underway, I will not enforce or create any transaction, but I will check that there is a transaction on the frame, or otherwise at runtime I will refuse to join that data control frame. Now you might get a little hint here as well of what options we have available for the data control scope. In the context of the always use existing transaction option, the data control scope option will in fact be disabled. Okay, so you cannot change it at design time. In addition, at design time, it will be already selected, or ultimately the shared data control scope option is picked for you. Why? Again, remembering what the shared data control scope does, it says that effectively the current bounded task flow and its associated data control instances want to share or join the current data control frame rather than creating a new one, which would create a boundary of our transactions. So it makes perfect sense why the data control scope option is set here, and obviously again you can see this sort of symbiotic relationship between the transaction options and the data control scope options. Again, as the slide alludes to here, there is considerations from this particular option, the always use existing transaction options, is if you call a task flow return with commit and rollback set, well, in this case, the commit and rollback will be ignored. Because if you remember from the previous slide, the always begin new transaction option, only that guy can commit and roll back all the data control instances attached to the frame. Now, if you actually create a task flow return commit or rollback in a always use existing transaction bounded task flow, at design time you will get errors on your task flow returns, but you can still compile and deploy the application. At runtime, simply put, that task flow return commit and rollbacks for the always use existing transaction are just ignored. Okay, so they have no influence besides the fact that your current bounded task flow will return based on that task flow return. So at this point, the always begin new transaction and the always use existing transaction options are kind of obvious why they exist. But there is a kind of a weird limitation that's introduced by the bounded task flow transaction options in the fact that it's not the caller who determines the transaction options, but the person that is being called, I should say the bounded task flow that is being called, that actually sets those. Now, if I was the caller and I knew that I had a transaction underway, I could therefore say to the bounded task flows that I was using that, hey, no, you shouldn't start a transaction, or maybe you should depending on what I'm doing. But because the way that the options are actually defined on the actual bounded task flow to be called, well, we hit a bit of a problem when, for instance, we're designing bounded task flows and we don't know how they're going to be called at runtime. Now you're going, what? How do we not know how they're going to be called? Well, say that I'm a bounded task flow programmer and I'm building you bounded task flows, but I'm going to sell them to you at a later stage. I could be building all sorts of bounded task flows, or maybe I'm just writing them to spec and I don't know yet how you're going to make use of my bounded task flows. Now the issue is when I write those bounded task flows, how do I know if there's going to be a data control frame open and a transaction on the frame as such? I don't. I have no way of knowing that. And so therefore setting the options either to always begin new transaction or always use existing transaction, if those were the only two options I had, we would get stuck and this would be a problem. To combat that, Oracle has a third option, and this is the use existing transaction if possible option. And this option is actually a runtime dynamic option, and basically it changes its behavior at runtime based on what's happening either in the data control frame or what you've set for the data control scope. I always like to call this the promiscuous option, because basically if there's a transaction going on, it will join it, but otherwise it'll go off and do its own thing. It doesn't really care. It doesn't have really high morals on what it's going to do. So how it works is at runtime, if you call this bounded task flow that has the use existing transaction if possible option turned on, okay, and also it has an isolated data control scope, then what this option will do is it will default at runtime to the same behavior as always begin new transaction. However, at runtime, if you have this option set on and you have a shared data control scope, then what actually occurs, well, it's really dependent on what's happening on the data control frame. If the data control frame that the bounded task flow is joining to doesn't have a transaction on the frame, it will start one. Okay, so we're defaulting back to the always begin new transaction behavior. However, if the data control frame does have a transaction on the frame, then this option basically defaults back to the use existing transaction, I should say the always use existing transaction on the frame. So here's an option the use existing transaction if possible option is one that only determines its behavior at runtime, and he makes himself in many ways more flexible because he just sees what's happening. Is there a transaction going on? Isn't there? Is there a data control frame which I can join? No. And based on what's actually happening at runtime, he will change his behavior. Now, the final option we need to consider in terms of the transaction options is no controller transaction. And in fact, this isn't actually one of the options. It's not related to the other options. It really means let's turn the transaction management off at the controller or the bounded task flow layer. So this option, what it says is, well, we're not going to add a token to the frame and track if a transaction's underway or not. In fact, what it says is, nope, none of that's going to happen. If the programmer wants to deal with transactions, they need to manage that at the individual data control instance layer themselves. So that means using the data control scope option to either spawn more data control instances or not, and in addition as well commit or roll back the individual data control instances, where the other transaction options at the bounded task flow layer are designed to more effectively group and commit and roll back heterogeneous services as a group. So the no controller transaction option is one that actually makes a lot of sense if you have exactly one data control instance, because in reality you're going to be committing and rolling back in only one instance, and to have all those extra services that are available for the other transaction options to commit and roll back a number of heterogeneous data control instances as a group, well, you don't have a group of them. You only have one. So the no controller transaction option makes a lot of sense for applications where you have a very simple data control model. But where you have a more complex model, such as, well, again, heterogeneous, disparate data control types that you need to group together in a larger bounded task flow set of chained transactions, then yeah, this is exactly why you want to use those options. Now the little caveat there again is, remember the example that I just talked about where you have maybe multiple ADF libraries with bounded task flows in their own root AMs. Now if you want to join those together into a composite application, okay, so that all the bounded task flows are calling each other, and you don't want to have all those root AMs for the one user session taking out numerous connections with the Oracle database, then one of the side benefits of the normal transaction options, again, always begin new transaction, use existing transaction if possible, and always use existing transaction, is that under the covers ADF BC, and well, I should say the ADF controller layer, will make sure that those root AMs use one connection for the effectively the transaction boundaries of your bounded task flows. But if you have no need for that facility, again, if you only have one ADF BC data control instance as an example, then you might as well stick with the no controller transaction option. Also, one little caveat is that I've seen people who try to mix bounded task flows that use the three original transaction options and the no controller transaction option. Now, why it is possible, it is actually quite difficult and hard to understand what's going on, because the data control frame is still being created thanks to the data control scope option, but when that transaction token gets created and is ignored based on the combination of options, can be very tricky to understand. So a guideline I'd like to put forth is you either use the three original transaction options for your bounded task flows, or you use the no controller transaction option, but you don't use them both, because it just gets too darn confusing about what's actually occurring in terms of the interplay of bounded task flows using the different options. So that concludes discussing the transaction options and what effectively they do and why you potentially use them and need to think about designing for them. Now what I'd like to do on the screen is share with you 4 links. This whole discussion on data control scope and transaction options has been discussed previously in our task flow transaction fundamentals white paper. And in addition, the 3 additional links here actually link to 3 separate demos that help to explain 3 scenarios of bounded task flows calling each other where they use the different combinations of options, and trying to make you understand the interplay of the data control frame, the transaction options, and so on and so forth. So take the opportunity now, having viewed this episode, to go and read maybe the document and look at those 3 demonstrations, and I think they will make a lot of what I've said today crystal clear. What we'll be looking at beyond this particular episode is we'll be talking about the task flow transaction, errors that can occur at runtime thanks to how you've actually configured the actual bounded task flow calls. And in addition, we look at a concept of what's called premature termination of task flows, which has got to do with the automatic rollback of transactions if the framework detects that the user has left a bounded task flow for some reason. Okay, so thanks for joining us today in this ADF Architecture TV episode. Hope you've enjoyed it, and we look forward to you joining us in the next episode very soon.